Okay, I can see that in order to factorize this, obviously there's no common factor. I recognize though that it's the difference of two squares. This expression here is the square of 4x, and this is the square of 1. And remember, we factorize that type of expression to two brackets, same thing in each bracket. So each bracket is actually starts with the square root of this thing, which is 4x, and it ends with the square root of 1, which is 1. And then one bracket will be plus and one will be minus. Just to check, by removing the brackets, 4x times 4x, well that's the 16x squared. When we multiply the outer terms together, we get minus 4x. When we multiply the inner terms together, we get plus 4x, and they cancel each other out. And we're left with 1 times minus 1, which is minus 1. So that's fine. Now, part A is something to do with part B, and I have to kind of look quite carefully, I think, to realise that. Okay, so let's have a look. We've got 1,599. What on earth has that got to do with this? Well, I realised that actually 1,599 is the same as 1,600 take away 1. And if I think of 1,600 take away 1 as 16 times 100 take away 1, all I'm doing is I'm comparing these two and trying to make them, trying to see really the similarity between the two. And notice that 100 is actually 10 squared. So this is the same as 16 times 10 squared take away 1. If you like, I could put that in a bracket to make it a bit clearer. In other words, these two are exactly the same if x is replaced by 10, which makes me realize that in order to be able to perhaps write 1,599 as the product of its prime factors, I could use this version of 16x squared minus 1. So I know that 16x squared minus 1 is 4x plus 1, 4x minus 1. So 16 lots of 10 squared minus 1, I could write it as 4 times 10 plus 1 in one bracket, and 4 times 10 minus 1 in the other bracket. Well, that's just the same. Well, 4 times 10 is 40. That's the same as 41 multiplied by, this is 40 take away 1, which is 39. And I'm on the right lines now. The only thing I've got to realise, though, is although 41 is a prime number, 39 isn't. I can see that 3 goes into that. So if I split my 39 into 3 times 13, 41 is a prime number, 3 is a prime number, 13 is a prime number. In other words, 1,599 is the same as, and I'm just going to write them in increasing order, 3 times 13 times 41. Okay, and it's quite a sneaky way, that being able to find a pretty nasty number as the product of its prime factors. Okay, be careful if you try to find 1,599 as the product of its prime factors without using part A. In other words, perhaps realizing that this can be divided by 3 and then dividing by 3 and ending up with 13 and 41, you would get no marks. The only way that you can do part A is using part B rather, is to use part A. Hence means using what you've just found. Okay, so if you use any other method, you won't get any marks. Be careful. Right, part 2 is also related. What we've got, 1.599 times 10 to the power 6. Well, I'm going to think how it's related. But basically, if I multiply this by 1,000, I get 1,599. In other words, 1.599 times 10 to the 6 is the same as 1,599. If I multiply that bit by 1,000 to compensate, I'm going to have to divide this one by 1,000. That ends up as just times 10 to the power 3. So if I want to write this number as the product of its prime factors, well, I already know that 1,599 is the same as 3 times 13 times 41. What I've got to do now is write 1,000, or 10 to the power 3, as the product of its prime factors. Well, one way of doing that, if you like, I'm going to write it as 10 times 10 times 10. That's just the same as 10 to the power 3. So in other words, I've got 3 times 13 times 41 times 2 times 5 times another 2 times 5 times another 2 times 5. Obviously, I could have done this a bit more quickly. In other words, I've got 2 times 2 times 2. Well, that's 2 cubed. I'm just going to write them in order of size again. 2 cubed times 3. And I've now got times 5 times 5 times 5. Well, that's times 5 cubed times 13 times 41 Obviously I need to write that up there, but that now is 1.599 times 10 to the 6th, written as the product of all its prime factors.